Could you able to hear me?
Yes, sir.
Guys, I'm audible to you. Can you able to hear me now?
Yes, sir.
Dan, Sandhya, Rani, Suja, Josh, Smita. I'm audible to you.
Yes, sir.
Yes, sir.
Yes, sir. Audible, sir.
Sorry, I'm not getting your voice anything. Can somebody speak out now so that I can able to see whether
Yes, sir. Audible. Hello.
How to change name? Ruklo undi.
my God. Hmm. Okay, then let's start with the session, guys. Let's start with the session. Let's see. We'll understand about from. Did you remember, guys, what we discussed in the last class? Anyone have you remembered about what we discussed in the last class? Okay, so that we'll start with the session.
Set.
Done. See, guys, we are in collections topic, and in the collections we discuss about something called as set. Actually, we discuss about a hash set which internally uses hash map object. Okay, actually we have discussed about hash set which internally uses a hash map object. Am I clear? Right. Guys, observe here. I told how does hash set identify whether it's a duplicate element or not. If you look at these customer objects, even though I'm adding the same customer object, but it is not identifying them as duplicates. Right, 101 101 name is a city Hyderabad. It's not identified these two customers as duplicates because in this customer class we have not overridden the hash code method. So when does set will identify that they are the duplicate elements? Yeah, if you don't override hash code method in the class, then the hash set can't identify duplicate elements, and it will store the multiple objects of that same with the same data. Okay, cool.
Yes, sir.
So just I want to show today, then we'll go to the linked hash set. Okay, we are actually looking forward to discuss about a concept called as linked hash set. So we'll start with the linked hash set today. Clear? Okay, let's go ahead, guys. Let's see. First I want to open the workspace. Okay, here Okay. It is not identified as a duplicate. That's what I told, right? This is not identified as a duplicate, right? That's why even the same customer is added twice, but we are getting what? The two customers are added to the set. But today, what we want to do, we are going to discuss about something overriding the hash code method. In the same example, just what we want to do, we want to override the hash code method. Correct? Now we'll override the hash code method. This is, let us go to the class customer. Okay, in the customer class, which method I want to override? A hash code method. I can I can right click, I can go to source, I can say that override hash code and equals methods. Actually, only hash code method is enough for me, but okay, because option is, I don't have option to override only hash code method. I have the option to override hash code and equals, both the method. That's why I'm overriding both of them. Otherwise, actually one method is enough. And now, guys, we will run this example. Now we can see here, after executing this example, guys, what are you able to see here? You can able to see what? Only one customer with ID 101 will be added to the set. Previous output were two customers, but currently one customer, because this is identified as a duplicate now. I remove the word not. That's the only small difference, right? So when you are practicing this example,
Yes, sir.
first you practice without overriding hash code method, and next you practice with the overriding hash code method and equals method. That is the way that how you are supposed to, test this application. Okay, now guys. Right. Let's go ahead. See, guys, what we are going to discuss now today. We'll see. Okay. We'll see what we are actually going to discuss today. Okay. Okay, we'll see what actually we are going to discuss today. Today we are going to yes. Yes, today we are going to discuss about a method called as what, class called as what? Linked hash set. So because already I have explained almost everything about hash set and hash map, that's why linked hash set, linked hash map is very simple. See here. Okay. Let's add the today's date here. 14th August. Okay. Guys, now here I want to start with a class called as what? Linked hash set. There is a class called as what? Linked hash set. Now we'll discuss about how the linked hash set class works. Actually, linked hash set class is an extension of hash set class only. Which means what? A linked hash set class is a subclass or child class of hash set class. So let's see. See, guys, I want to open what? Guys, linked hash set. I want to open the linked hash set class here. Okay. So linked hash set class extends what? Hash set, right? Means who is the base class? Linked hash set is called child class. Hash set is called parent class. The keyword is called what? Extends. Clear? Okay. Next, look at this. Everyone. Okay. Please understand and try to understand now. See here. Suppose we are creating a linked hash set object. I repeat again. Suppose we are creating a linked hash set object. Let's say, for example, what I'm trying to say is now, if I'm creating a linked hash set object, Okay. Whenever I create a linked hash set object, how much size? This 16 is a size of the hash map. 0.75 f is a load factor. And there is a value called true. I'll tell you, there is a constructor. Let's go to the superclass constructor. Okay. Tell me which object is created? Linked hash map object is created. Which means simple answer what? Everybody, simple answer is what? Whenever we create a linked hash set object, internally what object is created? Linked hash map object is created. And what is the size and capacity? By default, capacity 16, load factor is 0.75. It is exactly like hash map only. So linked hash set internally uses linked hash map. So there is a small difference between hash set and linked hash set. Okay, there is a small difference between hash set and linked hash set. See, what I'm trying to say, first statement. Okay, linked hash set is a child class of hash set. Linked hash set is a child class of hash set class. Okay, right? Next, linked hash set internally uses linked hash map. Linked hash map in linked hash map object. And same, the default capacity is 16. Here I no need to explain much because yesterday only I have explained everything. Today it's very easy to complete this linked hash set, tree set, all these things. The default capacity is 16 and the load factor is 0.75. You know all these things. Again, I no need to explain about who is load factor, what and all. Okay, that's why today I'm going to complete the class of the linked hash set very fast. So linked hash set has initial capacity of 16 and load factor 0.75. If you want, you can get linked hash set with what I can say, your own capacity. You can provide the capacity, you can provide the load factor. As you know, that load factor value could be in between 0.0 to 1.0. I told already, na, load factor could be what? It's a value which can be in between what? 0.0 to what? 1.0. Am I clear with this, guys? Next, we'll go ahead. So, what's the only difference? Internally, linked hash set uses linked hash map. Na? If you take, for example, hash set, elements are stored. Okay, elements are not stored in the same sequence. Correct. Elements are not stored in the same sequence. No? Suppose if you take the last example. If you look at the last example, where is the last example? Let me talk about the example of our hash set demo. Yeah, look at this now. See, first I'm adding, let's say customer. I want to remove this. Customer with ID 101, customer with ID 102. Come on. Let's say add one more customer. For example, hs.add. Okay, of new customer. Of, let's say, customer IDs 1, just one only. One is customer ID. Okay. Let's say, for example, customer name is, let's say, for example, C. Okay. And say, let's say, for example, customer location is, let's say, for example, okay, let's say, for example, BLG, Bangalore. BLR, Bangalore, for example. Let's say add one more, hs.add of. Let's say I'm adding one more customer, new customer. Okay, observe it, new customer of. Let's say customer ID is 11. Customer name is lowercase letter a. This customer name also a, but in lowercase. Let's say, for example, his location is, for example, let's say take Mumbai. Okay. CN, Chennai, for example. Okay. Now, all these elements are not stored in the same sequence. After 101, then 102, then 1, then 11 in the map. Because the elements are not stored in the same sequence. First, what is happened? Hash code is calculated of this element. And then bucket index is calculated after that. Then this element will be stored in that bucket as a key. And the value will be present. In the last class, I told you present is the object that we discussed in the last class, right? Present is a dummy object. Similarly, for each object, it will be, for each element in the added to the hash set object, the same thing will happen. Am I right? Now, I want to run this program. See, am I getting the elements in the same sequence? Like 101 after 102 after 1 after 11? No, right? I got 102 first, I got 11 next, I got 101 next, lastly 1. Because the reason is what? They are not stored in the same sequence, no? Okay, because what is calculated? Hash code is calculated for this element. Based on hash code, index is calculated for the bucket. Then this element will go to that bucket as a key and with a value called present. Right? Guys, can you give me some reply? Did you understand this point? Yesterday, whoever attended the class, you can understand and you can tell me the answer. Correct?
Yes, sir. Understood.
Can somebody reply?
Yes,
Did you
sir.
understand this point? Yesterday only we discussed it. Did you understand this point?
Yes.
Yes,
Thank you.
sir.
Suja, Sandhya, Rani. Yeah, correct.
Yes, sir.
Thanks, guys. So, elements are not stored in the same insertion order. First I am inserting customer 101. Next I am inserting 102. Next 1. Next 11. But it won't maintain the order, right? Whereas linked hash set, even though elements are stored in different buckets, it will maintain that insertion order. That is the only difference between linked hash set and hash set. How? In a linked hash set, whatever the element we add, for that element, 2 more links are included. One is called previous link and other one is called next link. So linked hash set is a double linked list implementation of map. Okay. So how do you understand it? I'll give a diagram. To understand it, I'll give a diagram. But first, let me write the point here. What's the point? Linked hash set. I'll tell you how. Linked hash set maintains the elements insertion order. Okay. How? Linked hash set is a double linked list implementation of set interface. Double linked list. Double linked list is one principle, data structure principle, last in first out, LIFO principle, FIFO principle, linked list principle. In linked list, we have single linked list, double linked list principles, tree principle, graph principle. Data structures are multiple principles. So linked list is a
Yes,
double
sir.
linked list implementation of set interface. These are all the points to know. Let's see how. So the element added in the linked list, the element added to the linked hash set contains previous and next links to maintain the insertion order. Now, let me give you all these things in the form of a diagram. That's the only difference between hash set and linked hash set. Hash set does not maintain the elements insertion order because it doesn't maintain the links. But linked hash set will maintain the elements in insertion order because it maintains the links. That is the only difference between what and what? Hash set and linked hash set. If you know the difference, then linked hash set concept is completed. We'll go to tree set. Okay. So first let me show in the form of a diagram. See. Guys, everyone observe it. Here I'm talking about what linked hash set of, let's say, integer. I can take integer or I can take a string better. Linked hash set of a string. Linked hash set of a string. Let's say LHS equal to new linked hash set. First, I'm creating the linked hash set class object. What's the default capacity and what's the default load factor for the internal linked hash map object?
16 and
16
0.75.
and 0.75. Default capacity is 16 and the default load factor is what? 0.75. Okay. Now what I'm trying to say is, guys, what I'm saying is, let's say, for example, I'm adding some LHS dot add of some string. It doesn't matter. Let's say, for example, a string is ABX. LHS dot add of a string called, okay, a string called, okay, let's say, for example, a string called BBB. Let's say, for example, LHS dot add of a string called ABC. LHS dot add of one more string called, let's say, for example, PQR. Leave about that. So what is happened now internally? This is what going to happen. This diagram will help you a lot. This is linked hash map object is created. I say this is a linked hash map object. Okay, linked hash map object is created. So this is the bucket index 0. Let's say this is a bucket index 1. Okay, I just want to move down. Next, this is bucket index 2. Okay, this is bucket index 3. Like this, blah, 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 bucket index 15. This is called what object is linked? Sorry. This is called what? Linked hash map object. This is called what, guys? This is the linked hash map object. Because internally linked hash uses linked hash map object only. This is 0 index. This is 1. Blah, 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 up to 15. This is 2. This is 15. This is 15. Right? Let's go ahead, guys. 0 to 15 are the bucket index. These are all called buckets. These are all called as buckets. These are all called what, guys? Buckets. So next I'll tell you what is happening. See, whenever we add any element, first of all, bucket index is calculated. Okay, bucket index is calculated. For example, I'm adding ABX. For example, it comes to this bucket. For example, the ABX is going to come into this place called as this bucket called index 2. Then what happens on this element will be stored here. While storing this element, it also contains 2 links. It's a first element now. It maintains before and after, previous and next links also. You have to understand like this. Okay, what's the value here? ABX. ABX is a value. This is previous link. This is a first element. Because it's a first element, what happens, you know, it's a previous link will be null. its previous link will be null. Okay. Currently its next link also null, but I'll tell you. Next BBB. Suppose BBB calculated, its bucket index is 1. What's the value first of all in this for this element? This is stored as a key. But here what's the value? Present. Yesterday we discussed na object present is a value. Present is a value. Next one is BBB. Second element added. First, what is calculated? Hash code is calculated. Based on that, what is calculated? Bucket index is calculated. Let's say bucket index is 1. Then this element will be stored as a key here. It also contains what? 2 links. Previous link, data, next link. Okay. Now, this is data, BBB. What I'm saying, this BBB element is added after ABX. That's why the next link of ABX, will point to BBB element. And the previous link of BBB will point to ABX. So here I'll use a different color. Okay, na? Because BBB came after ABX. Because BBB is inserted after ABX. It is maintaining the order now. Next, ABC, next element. ABC, sorry, bucket index is calculated. For example, the bucket index is 0. First hash code is calculated based on that what bucket index is calculated. Suppose the bucket index is 0, then what this ABC will come to this as a key, this element. So it will come here. Let's say, for example, its bucket index is 0. For example, it contains 2 links called what? Previous link, and also called what? Next link. There are 2 links is here. Correct. And also we have something called as ABC here. ABC here, done. Am I good with this? Am I good with this? Right. Now tell me, after BBB, ABC inserted. So BBB next will point to ABC. ABC pre will point to BBB. Pre means previous, na? Am I clear now? Like this. Okay, like this. Next, after ABC, what's next? PQR. For example, for PQR, the bucket index is calculated here. For example, for PQR, the bucket index is calculated here. Of course, what's the value of all these elements? I'm not writing the value because you know, object present will be stored as a value for each element. Present is stored as a value. Next, what guys? For example, bucket index calculated for PQR is somewhere in between 0 to 15. Let's say here. Let's say, for example, 14. Bucket index 14, for example. Then tell me here. It also contains previous link. It also contains next link. Right? Element value is PQR. Okay. Now tell me, PQR is inserted into the linked hash set after ABC. That's why ABC next link will point to ABC next link will point to PQR. So PQR previous link will be pointed to ABC. The previous link of PQR will point to ABC. Correct? I'm keeping arrows now so that you can understand who is going, which color and all. What is the value here? Present. After peak here, there is no next element now. That's why it is going to have null value. That's why it is going to contain null. Now this is null. This is null. Now guys, tell me now, how does linked hash set maintains insertion order? Who is the first element? Because the previous link is null, first element is ABX. Who is the last element? PQR, because its next element is next link is null. So PQR is the last element. ABX is the first element. After ABX, next element is BBB. After BBB, the next element is ABC. After ABC, the next element is PQR. After PQR, there is no next element, so it is null. Nothing but it will maintain like order. If I'm displaying the linked hash set, I'll get the same order. First ABX, then BBB, then ABC, then PQR. Now, did you understand about how the linked hash set is working? I want to keep this diagram for you, folks. That is the only difference between what and what? Hash set and linked hash set. Okay. Hash set and linked hash set. So I want to insert this picture into the diagram, into our document. Insert the picture. Okay, guys. So please understand that this is how the linked hash set works. That is the difference between what and what hash set and linked hash set, remaining all same. So how does it identify the duplicate element? If I add one more time BBB, same hash code only. If I add one more time ABX, identified as a duplicate element because of hash code. Same concept. What and what are same? Hash set and linked hash set both are one and same, but only some difference is there. What is the difference? It maintains the elements insertion order. How does it maintain? Because it is a double linked list implementation, the element after the linked hash set contains previous and next links to maintain the insertion order. This is the only difference between what and what? Hash set class and linked hash set class. Am I clear with you guys? Am I clear with you? So did everyone
sir.
understood about how linked hash set is working? Okay, na? Correct?
Yes, sir.
Good. Good, guys. Everyone? Everyone, did you understand about how linked hash set is maintaining insertion order? Because it has links. If I display the linked hash set, who is the first element displayed? Who is going to be the first element for me? ABX. Who is going to be the last element for me? PQR. After ABX, what is the next element displayed? BBB. Because ABS next is BBB. BBB next is ABC. ABC next is PQR. PQR next is null. So how ABX is identified as the first element? Because the previous is null. Previous null means first element. Next null means last element. Next null means last element. Am I clear with you? Am I clear with you guys? Am I clear with you? Okay, good. Let's see. Let's see how it's going to happen. Let's go ahead. Actually, I'm not getting your voice. Actually, I don't know. Let's go ahead, guys. We'll see how it's going to work out. So next, we'll see the program, guys. Okay, I can take linked hash set of customers or linked hash set of strings or linked hash set of integers. It doesn't matter, but it will maintain the insertion order. If you look at the same example, this example only, tell me instead of using hash set, I want to use what? Linked hash set. I repeat again. Okay, guys. What I'm saying now, instead of using linked hash set, instead of using hash set, I just want to change to linked hash set. Object name I want is HS only. Reference variable can be any name. Reference variable name is HS. I can use any name, doesn't matter. So linked hash set of customer, HS is equal to new linked hash set. Then I'm adding HS dot add of the customers 101, 102, 1 and 11. If I run this program, I will get elements in the same order. Okay, but one thing, they are not stored in the same order actually. They are stored according to the bucket index only, but they have links together. They are connected with links. Okay, by using those links only, linked hash set is maintaining the insertion order. Linked hash set is maintaining the insertion order based on the links between the elements, like previous link and next link. So if I run this program, you see first element is 101, 102, 111. You see 101, 102, 111. Am I clear now? Am I clear with this, guys? This is called what? Linked hash set. It maintains the insertion order. They are not stored exactly in the same order. They are stored in different buckets based on the bucket index. But so they are stored in different buckets. But okay, they are stored in different buckets. But they maintain insertion order because of the previous, next, such kind of elements. Right? Okay, guys, let's go ahead. Let's go ahead and see. This is the linked hash set program that you can practice and see really are we getting in the same order or not. Yes, I want to copy this for you. Linked hash set program. And even after copying this program for you, I just want to write the output also, because here the output is what? Exactly same order you are getting elements. But they are not stored in same order. They are stored according to bucket indexes, but it maintains links to maintain the insertion order. That is called linked hash set. Remaining all same. For loop you can use like for each iterator. Okay, all these things you can use. And a linked hash set also contains some additional methods. Like we can call the methods like add first, add last. I'll show you the methods. If you know linked list, then automatically, if you know the list concept and if you know the hash set, then remaining all, the collections concept is very easy. Remaining all simple. So first I want to copy the output. Now look at the linked hash set class methods. I'll go to linked hash set class methods. If I open the class called linked hash set, you can see. These are all okay. Okay, right. If you observe the methods, except a split iterator, and you don't have any additional methods. See, the methods like hash set methods is empty, contains, add, clear, clone, iterator, remove, size, remove all, equals, hash code, add all. Okay, methods from set interface like add all, clear, contains all, equals, hash code, is empty, iterator, remove. So thing is what, in a linked hash set, you're not finding any new methods. Okay, you're not finding any new methods. Okay, good. So just only difference between hash set and linked hash set is that one only, insertion order. If I want to maintain elements insertion order, then I should go for linked hash set, where I don't want to allow the duplicates, because linked hash set or any set, tree set, linked hash set, any set object does not allow duplicates. But how does it identify whether it's a duplicate element or not? Based on hash code. Correct? Based on hash code. That's what I told even yesterday, and even I'm explaining it for today also. Next. What's the next? I just want to say the questions. There are 4 questions which are common for list, set, and all. I'll copy those questions. On the top, I have already given the same questions for linked list. Same questions I gave for array list also. Similarly, the same questions are there for hash set, and the same questions are even there for linked hash set. What are the 4 questions? Is linked list object is thread safe? Can you make linked list object is thread safe? Linked list object is mutable or immutable? Can we make linked list object as immutable? What is the difference between array list and vector classes? Like this, you have some questions now. These are first 3-4 questions. The first 4 questions are common for hash set and also for linked hash set. So I want to copy this, but I want to change the names. And I want to change the methods as well, okay? So first, I want to add 4 questions. Question is what? First, I'll write hash set. Is hash set object is thread safe? Okay, object answer is no. Same like list only. Hash set object is not a thread safe object. No. So can you make a hash set object as thread safe? Answer is yes. We can call synchronized set method, not list. Synchronized set method of collections class. So how can I write set of employee set2 is equal to collections dot synchronized set of set1. Okay guys, what's the method name? Synchronized set. Same as the previous. Now here, hash set object is mutable or immutable? Answer is mutable. So can we make hash set object as immutable? Yes. Yes. How can we? We can call unmodifiable set, not list. Instead of list, add set. So what I can write here? Set2 is equal to okay, collections dot what I can write guys here? Unmodifiable set of set1. Okay, now guys. So now did you understood this? 4 questions. Now these 4 questions are for hash set, na? Same questions applied for linked hash set. Next 4 questions. Is linked hash set? I will add one word, linked. Is linked hash set object is thread safe? Answer is no. Can you make linked hash set object as thread safe? Answer is yes. How? The same thing. Set2 is equal to collections dot synchronized set only. Method name is synchronized set only of set1. Instead of set1, you can write LHS1, linked hash set1. LHS1, LHS2. Just for your reference to know. LHS2 is equal to, I can do like this. Okay, linked hash set update is mutable or immutable? Answer is what? Mutable. Can we make linked hash set update as immutable? Answer is yes. How? Unmodifiable set. Same answer. Let's say it is LHS1, it is LHS2. Guys, am I clear with you now? Am I clear?
Yes, sir.
Yeah. Okay, good. Good. Okay, same questions. So 8 questions now. 4 on hash set, 4 on linked hash set. Next. We will go with the tree set class. First of all, we'll go to the diagram again. On top, we have a diagram. Yeah. See, so far we completed what linked hash set is completed. Hash set already completed yesterday. Today we completed what linked hash set. Next, we are going to discuss about one more class called tree set. We know that what tree set class implements navigable set. Navigable set extends sorted set. Sorted set extends set. Am I clear? Tree set is a class which implements navigable set. Navigable set is an interface, extends sorted set. Sorted set extends set. This is for tree set will store elements in sorting order. Natural sorting order. Okay, tree set will store the elements in natural sorting order. Tree set internally uses tree map. Tree set internally uses what? Tree map. Okay, linked hash set internally uses what? Linked hash map. Hash set internally uses hash map. Common concept is what? They store the data in key value pairs. Bucket index are from 0 to 15. By default is 16 capacity. Load factor is 0.75. Right? If you want to store the elements, okay, try to understand me. Everybody. If you want to maintain elements in sorting order, not in insertion order, in sorting order. Linked hash set maintains in insertion order, but I want to maintain them in sorting order. If you want to maintain the elements added to the set in sorting order, then you need to go for tree set class. Of course, a tree set implements navigable set that extends to sorted set. Okay, there are some methods in sorted set. There are some methods in navigable set. And then we have a tree set class. Let's open the sorted set and navigable set. Let's identify the methods in them. Because set interface methods we know already. Add method, clear method, remove method. Okay, add all method. Okay, right? Iterator method. So, to array method. These are common methods, right? So, set has some methods. All the methods are inherited from collection interface. Now, we'll see what sorted set. Okay, sorted set contains methods. We'll see what are they. Then navigable set also contains methods. Let's see what are the methods in these two. Then we'll discuss about tree set. But when to use tree set? Suppose if you want to maintain the elements in sorting order, not insertion order, in the sorting order. In the sorting order, then you go for tree set. Tree set internally uses tree map object. Linked hash set internally uses linked hash map object. Hash set internally uses hash map object. Okay, so now today we'll discuss about how tree set works. Okay, for that, first I'll explain methods in sorted set, methods in navigable set. Let's see what are the methods in sorted set. Let's see what are the methods in sorted set interface. What are the methods in navigable set interface. Then we'll discuss about tree set. Okay, now let's start. Sorry, I will start with yes. Which one I'm talking about? Java.util.sorted set. Next, I also want to open navigable set. Look at this. First, I'll talk about sorted set. You see, sorted set is what? Interface. Sorted set interface extends a set interface. Set to interface to interface is extends keyword only. Interface to interface is extends keyword. Sorted set extends set. Interface to interface is extends keyword. We'll come here. We'll see the methods. Okay. If you want to get the comparator object, then we can call comparator method. That generally we don't call. Leave it. But coming to sorted set, there is a first, returns the first element, last element, head set, tail set, subset, 3 methods. Split iterator, we'll discuss in Java 8 features. First element, last element, tail set, head set, and subset. 5 methods. If you know, that's enough. These are the methods of what? Sorted set. What about all these add all, clear, contains, equals, hash code, is empty, iterator, remove? These are all to array and all. These are the methods of set interface. So we know that set interface methods are inherent to sorted set also, because sorted set is a sub interface or child interface. Okay. So now did you understood? So now did you understood about what I'm trying to say? Did you understood about what I'm trying to say? Yes. Did you understood about what I'm trying to say? Everyone? So are you clear
Yes,
with,
sir.
are you clear with all these things, right? Okay. Now, what first element returns? First element of the list, of the set. Last method returns last element of the set. Head set, it will returns a portion of the set whose elements are strictly less than the 2 element. I'll tell you what does it mean. Tail set means from this element. Head set means up to this element, but not including the element. It is exclusive the element, less than this element. But 2 element, from element means greater than or equal to from element. Head set, tail set, subset, from element to 2 element. When you are passing from element and 2 element, from element is included, but 2 element is excluded. That's called subset method. Let me write first of all these methods. I'll show you example, don't worry. Okay. While working with a tree set, I'll show you. So first we'll see methods of sorted set. Now we're discussing about methods of sorted set. Interface. What are the methods of sorted set interface? 5 methods is enough to know. First, returns first element. Returns the first element. Second one is last, returns the last element. Okay. Next one is head set of 2 element. Okay, returns. Okay, returns a set whose elements are less than the 2 element. Not equal to also, only less than. But whereas a tail set is from element, we are passing from element, so you should pass the from element. Returns a set whose elements are greater than or equal to the 2 element. Next we have a subset method. S small, S capital, subset. Both from element to element. Two arguments will pass. Returns a set between from element inclusive to two element exclusive. So we have various methods here. First method, last method, head set, tail set, and subset. These are the methods now. 1, 2, 3, 4, 5. These are the methods. First element returns first element, last returns last element, head set, tail set, subset. Guys, 1, 2, 3, 4, 5. These are the methods of sorted set interface. You will see all these things in the tree set example. Okay.
Subset of
Next, we'll go ahead with the
say yes is the
navigable set. There are many methods are there here, but some of them that we'll discuss now. Navigable set means we can navigate now. Here also we have a head set method, and we have tail set method. Okay, and also we have subset method. These are common, but if you want, we can reverse it, and we can get in descending order, reverse order. Suppose elements are sorted in ascending order, but you want to get in descending order, then you can call descending set. Okay, right? Ceiling means returns the least element. The least element which is greater than or equal to the given element. Greater than or equal to the given element. Generally, we don't call these methods at any time, but still, descending set is one method. Floor. Floor means returns the greatest element where the element less than or equal to the given element. The greatest element greater than or equal to the given element. That is, the greatest element less than or equal to the given element is floor method. Ceiling method returns the least element which is greater than or equal to the given element. Ceiling means upper bound, floor means lower bound. Okay, right? Good. And we have methods like higher, lower. Generally, we don't call it any time, but still there are methods. Higher. But higher returns the least element in the set strictly greater than the given element. Not even greater than or equal to, not like ceiling. Higher only. Higher of the given element. Lower of the given element is lower. The greatest element in the set which is less than the given element. Lower of the given element, higher of the given element. We pass an element, we want its higher element. We pass an element, we want its lower element. Higher, lower. Ceiling, floor. Descending set. If you want to get in reverse order. If you want to remove first, and you can remove last. And similarly, we have pole first, pole last. Pole first, pole last returns null if the set is empty. But remove first, remove last methods will throw exception. If you want to reverse the set, reversed method. You want to reverse the set directly. Reversed method, if you call, the elements are reversed in the tree set object. And remaining, you know, tail set, subset, head set, these methods, you know. Okay, all the methods are not required, but still, just we'll see some of the methods to know. Okay, so what's the difference between pole first and remove first? Pole first will retrieve and remove. Remove first also will remove. Will remove element and return the element, right? It also will do the same. But if the list is empty, if the set is empty, it returns null. But remove first is not like that. It will throw an exception. If I click on this, you can still throw an exception. No such element exception if the collection is empty. No such element exception. Are you getting my point? No such element exception. But pole first will not do like that. Remove first and remove last will do that. So let me first add some methods now. What next I want to add? Methods of navigable set interface. Let's say, for example, I'm writing one method called as descending set. Okay, just now I have shown you. Once again, I'll show you the method. There is a method called as descending set. You can see on top methods list. There is a method called as descending set. Returns a reverse order view of the elements contained in the set. Better I'll copy the same definitions here. Instead of manually typing, I just want to copy. Okay, next. Okay, so the next, let's see, the method name is ceiling floor. Okay, I just want to say higher, lower. Generally, we never call ceiling flooring, but I want to call the methods like higher of element. Similarly, we have lower method also. There is a method called as higher. Returns the least element in the set strictly greater than the given element, or null if there is no such element. Instead of writing it by myself, I just want to copy it so that we can finish it fast. Next.
Sir, there is a format painter. Is there?
Obviously, lower is a method of element. We have a lower method. Correct. Let's see how the definition of lower. Same, but it returns greatest element less than the given element. This is called lower method. What next you want? Pole first, pole last methods are there. Similarly, remove first, remove last methods are there. Head set, tail set, subset. Again, I don't want to write them because those methods are already I covered in sorted set. They are into navigable set also. So, pole first. There is a method called pole first. Okay, there is a method called as pole first, returns and removes the first element. Just I want to change the font, increase the size. Okay, like a pole first method, we have something called as pole last. Okay, pole first method, like pole first, we have pole last also. Okay, just I want to change the message. Removes the last Last element means highest, not lowest. Highest element. So let me change the font size here. Like pole first, pole last. We have the methods like what, guys? Sixth one. Remove first, remove last. Remove first and remove last. Like remove first, we have remove last also. But difference is what? Remove methods will throw exception. No such element exception. But whereas poll methods returns null if the set is empty. So we have a difference, right? Okay, done. Similarly, remove last. Like remove first, we have remove last. Remaining methods I'm not copying. Like what methods? I don't want to copy the methods like head set, tail set, subset. I don't want to copy those methods. Return removes and returns the last element of the collection. Enough now. These are the methods of which one, guys? Navigable set. Okay. Now, guys, so far did you understood about all these things? So far, what we discussed in sorted set and navigable set. Okay. So am I? Yeah, just I told about methods only. Na? Please give me reply by everyone. Like Akshay, Dan, JP, Ketan, use chat box, and Lakshmi, Nitish Singh, Samir Kumar, Suresh, everyone.
Yes, sir.
Yeah.
Yes, sir.
Good. Okay. Actually, what I told you just now, we are going to look at about tree set class. Because a tree set is a class. Tree set class implements navigable set. Navigable set extends sorted set. Because you see the diagram on top, the diagram says same thing. Which means in tree set, we have all these operations. In a tree set, we have descending set method. We can use lower method. We can use higher method. Or we can use pole first, pole last, remove first, remove last. All these methods we can use in tree set. But we can't use them in linked hash set, or we cannot use them in hash set. But we can use in tree set. These methods are there in tree set, but not there in hash set class, or but not there in linked hash set class. Can I call lower method in hash set or linked hash set? I can't.
No.
Because these methods are not there. Okay, pole first, pole last, peak first, peak last, head set, tail set, subset. Can I call these methods on linked hash set? I can't. But I can call them on
Tree set.
I can call them in tree set. Okay. Okay. Our next thing is what we want to discuss about a class called as a tree set. Tree set is our class. Okay. What's the point I want right here after tree set? I want to say that I want to write that tree set class
Tree set. Yes.
implements
So navigable.
set. Navigable set interface. And this navigable set interface extends
Set interface.
sorted set interface. And this is sorted set interface extends set interface. So these are order na? Set to sorted set to navigable set to tree set class. That's the statement. Tree set internal uses what? A tree map object. Tree set internal uses a tree map object. Like a linked hash set uses linked hash map object. Hash set uses hash map object. Tree set uses tree map object. But what tree map speciality? What's the tree set speciality? It maintains the elements in sorting order. What's the specialty of linked hash set? It maintains the elements in insertion order. Tree set does not maintain in insertion order, but it will maintain them in sorting order. Okay. Hash set, it does not maintain insertion order, sorting order, both. That is plain hash set. Hash set just simply stores elements, but doesn't maintain orders, like either insertion order or sorting order. That's the difference between hash set, linked hash set, and tree set. Am I clear with you?
Yes, sir. Clear.
Did you understand the three differences? Folks, who will maintain insertion order of the elements? Can you tell me answer in chat box?
Tree set.
Linked hash set.
Who will maintain elements insertion order? Which set will maintain insertion order?
Linked hash set.
Linked hash set. Correct. Linked hash set is correct answer, right? Good. Okay. Which set maintains sorting order of elements?
Tree set.
Which set maintains sorting order of elements?
Tree set.
Tree set.
Tree set. Okay. Which set does not maintain order of elements?
Hash set.
Hash set.
Either insertion order or sorting order.
Hash set.
That is hash set. So you got the three classes now. One is a hash set. Next one is linked hash set. Now today we are also discussing about tree set. Okay. Tree set internally uses which map? Tree map. Linked hash set internally uses what? Linked hash map. Hash set internally uses what? Hash map. So you got hash map, linked hash map, tree map. For the default capacity 16. For the default load factor 0.75. These are all clear things.
Yes, sir.
Right? Just I wanted a statement here. Statement is what? Statement is what? Tree set class internally uses a tree map object. Tree set class internally uses a tree map object. Okay, what's the default capacity? Same. The default initial capacity is 16 and the load factor is 0.75. Okay, 0.75. Correct? Correct. Okay. So what tree set will do? Tree set maintains elements in not insertion order, maintains elements in sorting order. Okay, maintains elements in sorting order. Sorting order or natural sorting order. Natural sorting order means if it is strings, alphabetical order. If it is numbers, according to the values of the numbers, like that. Natural sorting order. Tree set maintains elements in natural sorting order. Okay. Okay. So how tree set works and all we'll discuss in the further class. Further class means on tomorrow, as you know, tomorrow is holiday. There is no session for tomorrow, August 15th. So tomorrow is holiday because of Independence Day. And we will come back on day after tomorrow. That is on Friday.